on the high plateau of Chile's Atacama Desert. Atop Cerro Pagan stands a giant eye, the very large telescope of the European Southern Observatory. Its daily work is to silently gaze into the depths of the universe. Each night, it records vast amounts of data. This data consists of countless starlight and radio signals. Day after day, astronomers analyze this information, hoping to uncover new cosmic patterns or discover new celestial bodies. It was a seemingly ordinary night. The telescope conducted its routine sky survey as usual. Countless photons traveled long distances to reach the primary mirror, where they were focused by a precise optical system onto sensors, converted into digital signals processable by computers. Automated programs sifted through that day's observational data. Suddenly, an inconspicuous alert triggered. The program flagged a celestial body with an anomalous trajectory. Its path did not match any known solar system object. Initially, researchers suspected it might be an error, perhaps sensor noise or a data processing glitch. But after repeated verification and recalculation, they ruled out these possibilities. This signal was real. It was a visitor that had just entered the inner solar system. Preliminary orbital calculations delivered an even greater shock. Its hyperbolic trajectory unequivocally indicated an origin from interstellar space. This signified it was not born within our solar system, but had traversed vast interstellar space to arrive here. This marked humanity's first real-time detection of such a celestial body. Previous discoveries like Oumuamua and Borisov were only identified after their passage. This time, we captured its entry into the inner solar system. The entire astronomical community is now cautiously excited. Following the naming conventions of the International Astronomical Union, this object has been formally designated 3I Atlas. The 3I signifies it is the third interstellar object discovered by humanity, while Atlas symbolizes its mission to bear the weight of revealing cosmic mysteries. The discovery team immediately shared the information with global peers, a time-honored tradition in astronomy aimed at collaborative research. Soon, telescopes worldwide adjusted their sights. Another large survey telescope in Chile joined the observations, providing more precise positioning and photometric data. These early observations aim to confirm its fundamental orbital parameters and gather basic physical properties like brightness and color. As data accumulated, its extraordinary nature began to emerge. Its velocity far exceeded that of typical solar system objects, reaching over 137,000 miles per hour. Even more unusual was the astonishing precision of its trajectory, as if meticulously calculated rather than scattered by natural gravitational forces. This discovery immediately evoked comparisons to previous interstellar visitors, particularly the oddly shaped, enigmatic Oumuamua. Oumuamua's anomalous acceleration remains unexplained to this day, and this new visitor appears to bring even more mysteries. Great moments in scientific discovery often begin with such faint glimmers, not always grand announcements or universally celebrated revelations. More often, they lurk within vast streams of data, awaiting researchers to unearth them with patience and ingenuity. This is precisely the charm and value of fundamental scientific research. Our exploration of the cosmos is not always driven by immediate applications, but stems from humanity's deepest, purest curiosity, the desire to understand where we come from and where we stand. The emergence of this mysterious visitor coincides with a pivotal moment. Humanity stands on the eve of a new explosion in space exploration capabilities. The James Webb Space Telescope is now operational, capable of analyzing stellar spectra with unprecedented precision. Multiple Mars rovers are active on the surface of the red planet, while private companies actively develop next-generation spacecraft. We possess greater exploration capabilities than at any point in history. Thus, the arrival of 3I Atlas could not be more timely. It provides us with a unique research sample, a carrier of matter and information from another star system. By studying its composition and structure, along with its trajectory, we may glimpse the formation processes of exoplanetary systems, and even understand the distribution of matter in interstellar space. Such knowledge is crucial for comprehending cosmic evolution. Of course, the most captivating possibility remains its potential artificial origin. Though this remains a scientific hypothesis requiring rigorous verification, its very plausibility ignites global public imagination. Humanity has never been this close to a possible answer. To that age-old question, are we alone in the universe? The essence of scientific inquiry is precisely this peaceful process. It neither presumes answers nor fears disruptive discoveries. It advances solely guided by evidence and logic. Through unhurried research and tranquil learning, we approach truth. Every scientific revolution in history began with such anomalies. When Newton saw an apple fall, he contemplated the nature of gravity. When Galileo pointed his telescope at the stars, he discovered Jupiter's moons. When Penzias and Wilson detected the cosmic microwave background radiation, they initially thought it was caused by pigeon droppings on their antenna. Many groundbreaking discoveries arrive quietly, cloaked in ordinary appearances. They demand researchers possess keen insight and open-mindedness. Facing the 3I Atlas, astronomers uphold this spirit. They gather every bit of data and propose diverse hypotheses, considering natural explanations while remaining open to more extraordinary possibilities. This openness is the cornerstone of science's continuous progress. Now, let us temporarily set aside subsequent detailed analysis and return to that initial moment that changed everything. In the quiet control room of the Chilean observatory, researchers stared at the flickering light point on the screen. It represented a journey spanning light years across the cosmos, and might carry a civilization's greeting or secret. This light point moved at a constant speed, through vast, unexplored voids of space. Its trajectory pointed toward the inner solar system, approaching the orbits of Mars and Earth within months. News of this discovery swiftly spread through academic channels. Major observatories worldwide began tracking it. Professor Avilab of Harvard University also noticed it. He was renowned for his previous in-depth research on Oumuamua. This time, he swiftly assembled a team to conduct independent analysis. Their calculations confirmed the trajectory's anomalous characteristics, and began seriously considering the hypothesis of its potential artificial origin. All this unfolded beyond the public eye, on preprint servers and academic mailing lists. Scientists engaged in intense, yet rigorous debate. They debated the reliability of the data and its interpretations. This is how the scientific community self-corrects and advances. It wasn't until multiple science media outlets simultaneously reported the discovery that the public realized an extraordinary moment might have begun. Social media buzzed with excitement and speculation, but information from professional institutions remained restrained. They emphasized that observations were still in their early stages, and that more data was needed before drawing any reliable conclusions. This cautious approach is the professional integrity of scientists. A fundamental principle is to avoid overinterpretation when evidence is insufficient. Yet it cannot be denied that this celestial object is extraordinary. It challenges many of our common understandings about celestial motion. It knows no borders, involves no politics, only the pursuit of cosmic truth. Researchers worldwide share data and coordinate observation plans, all to understand as much as possible about this mysterious visitor. This spirit of cooperation is one of humanity's finest qualities. When we gaze upon the stars, we are one family, together facing the wonders and unknowns of the boundless universe. The arrival of 3I Atlas marks a beginning, not an end. It opens a window into the deeper reaches of the cosmos. Through this window, we may glimpse new worlds, and even redefine our own place in the universe. In the following video segments, we will delve into the details, analyzing how its trajectory defies natural expectations, exploring why its physical properties are so peculiar, and rigorously assessing its potential as extraterrestrial technology, guided by clear logic and robust data, to guide you through a rigorous journey of scientific reasoning. Whatever the final answer may be, this process itself represents the pinnacle of human rationality and curiosity. Now the curtain has risen, and the story unfolds. Let us approach the cosmic puzzle presented by 3i Atlas, with a calm mindset and a thirst for knowledge. Initial observational data converged at the International Astronomical Union's Minor Planet Center. Astronomers worldwide began preliminary orbital fitting for 3i Atlas. Using initial day's observations, they calculated its fundamental orbital parameters. The results revealed a highly oblique, hyperbolic orbit relative to the ecliptic plane. Its orbital eccentricity significantly exceeded 1, unequivocally indicating an interstellar origin. This signifies immense kinetic energy sufficient to escape the sun's gravitational pull. It did not originate within our solar system's gravitational confines. Rather, it is a visitor from the distant interstellar space that has entered our home. More precise calculations revealed its astonishing flight velocity, exceeding 137,000 miles per hour. This speed far surpasses the movement of ordinary comets or asteroids within the solar system, and even outpaces the fastest human-launched spacecraft, Voyager 1. Such high velocity is a hallmark of interstellar objects, as they traverse the vast voids between stars. Yet 3i Atlas's velocity and trajectory precision surpassed all expectations. Its flight path exhibits a mathematically perfect elegance, not following chaotic or randomly scattered natural gravitational trajectories, but traversing the solar system along a meticulously calibrated path. This path will guide it to successively approach the orbits of Venus, Mars, and Jupiter. This series of close flybys is known as the gravitational slingshot effect, a technique routinely employed by aerospace engineers to conserve spacecraft fuel in orbital design. Yet Atlas's trajectory appears optimized to perfection. By skillfully harnessing the gravitational fields of inner solar system planets for steering and acceleration, its perihelion will be precisely controlled to lie on the opposite side of the Sun, an ideal vantage point for observing Earth while remaining concealed. Professor Avi Loeb of Harvard University's Department of Astronomy immediately noticed this anomaly. His team ran millions of orbital simulations on supercomputers to identify a natural process capable of explaining such precision. The results were perplexing. The probability of this trajectory forming naturally was extremely low. Dr. Loeb calculated the natural occurrence probability to be less than 2 in 10,000. This probability equates to rolling the same number on a die 20,000 consecutive times. Statistically, this constitutes a significant anomaly. Such a minuscule probability compels us to consider non-natural explanations, or acknowledge a substantial gap in our understanding of interstellar celestial dynamics, compelling us to rethink the dynamical environment of our solar system, and whether more such travelers exist among the stars. Perhaps interstellar space is not as empty as we imagined, but teeming with celestial bodies of all sizes. Like cosmic drift bottles, they carry distant messages. 3i Atlas is merely the first we have opportunely captured. As observations continue, its story will gradually unfold, whether as the most peculiar natural phenomenon, or as evidence of the first extraterrestrial technological presence. It is destined to leave an indelible mark on scientific history. And we are the very witnesses of this historic moment, jointly observing this chapter through the eyes of global scientists. The peaceful essence of scientific exploration shines brightly in this moment. Concurrently, Optical observations revealed its unusual physical properties. 3I Atlas's diameter is estimated between 3 and 15 miles. This scale far exceeds previously discovered interstellar objects like Oumuamua and Borisov, making it the largest interstellar visitor humanity has observed to date. Its immense size alone rules out the possibility that it is a common comet, as the Oort cloud at the outer edge of the solar system rarely ejects such large bodies. Its shape remains an unsolved mystery. Early light curve observations show highly regular brightness variations. But unlike typical elongated asteroids, it does not exhibit dramatic fluctuations in brightness. Instead, it suggested a complex, non-simple geometric structure. More puzzlingly, it was enveloped by a teardrop-shaped, hazy halo. Astronomers refer to this halo as a coma. Typically, comets form similar structures as icy material sublimates near the Sun. Yet 3I Atlas's coma differed from any known cometary coma. Spectral analysis of its coma by Chilean telescopes revealed exceptionally high reflectivity, exceeding typical cometary or asteroidal reflectivity by a factor of 10 or more. This indicates its surface or surrounding environment is coated with a highly reflective material. This substance could be highly pure water ice, or some as yet unidentified metal or compound. The high reflectivity also explains why it was detectable from such a great distance. The James Webb Space Telescope trained its powerful infrared spectrometer on it and obtained the most detailed compositional data to date. Analysis revealed a significant presence of carbon dioxide ice particles within its coma. Its abundance exceeds that of any known solar system comet by more than 8-fold. Such a high concentration of carbon dioxide is extremely rare in natural comets. This could indicate a primordial body formed in an extremely cold environment. Alternatively, it may possess a non-natural internal source, such as exhaust or coolant from some technological process. The Hubble Space Telescope sought to decipher the structure of its core. Despite the vast distance, Hubble's high-resolution images provided crucial clues. The images revealed that 3I Atlas maintains perfect rotational stability as it spins, unlike most natural asteroids tumbling erratically through space. Its rotational axis appears firmly fixed in one direction. Such stability typically requires either a highly uniform internal mass distribution or the presence of some active attitude control system to maintain equilibrium. Hubble's images also hint at irregular bright spots on its surface. These spots exhibit reflective properties markedly different from the surrounding dark material. They display a high reflectivity characteristic of metallic surfaces. Analysis by the University of California, Berkeley team suggests these bright spots may be caused by exposed metallic surfaces. Such extensive areas of exposed metal on a natural celestial body are highly unusual, as space weathering typically causes metallic surfaces to darken rapidly. Another key discovery came from measurements of its thermal radiation. The Spitzer Space Telescope observed it when it was still far from the Sun. It found that the heat it radiated far exceeded the solar energy it could receive at its current position. This indicates that 3I Atlas has an independent internal heat source. This source could stem from the decay of radioactive elements. It could also originate from some unknown internal energy-generating mechanism. For a small celestial body, sustaining such a long-lasting internal heat source is difficult. The European Space Agency's Gaia mission provided another crucial piece of information. By tracing 3I Atlas's path before entering the solar system, astronomers attempted to locate its possible stellar origin. Calculations indicate it likely came from the direction of the Milky Way's thick disk region. Stars in that area are typically extremely ancient, reaching ages of up to 10 billion years. If 3I Atlas indeed originated there, it may have traveled through interstellar space for an extraordinarily long period. Its trajectory also reveals another subtle anomaly. During its passage through the solar system, it exhibits a faint yet persistent deceleration. This deceleration cannot be fully explained by the sun's gravitational pull alone. Some non-gravitational effect appears to influence its motion. Such non-gravitational effects are common in comets, typically caused by material outflows. However, the deceleration observed in 3I Atlas appears too smooth and controlled, unlike that caused by random, localized outbursts. All these anomalous features combined paint a picture vastly different from any known celestial body. It is a massive, highly reflective object with peculiar opacity. It travels along a mathematically perfect trajectory. Its interior may harbor a heat source, and its surface may feature metallic patches. Its motion is influenced by some unknown non-gravitational effect. Each individual feature might yield a strange natural explanation. But when all these characteristics appear simultaneously on a single object, the probability becomes minuscule. Global teams of astronomers began drafting preliminary analysis reports. These reports were published on authoritative academic preprint websites for peer review and critique worldwide. The scientific community's mood was both excited and cautious. Excitement stems from the possibility of an unprecedented discovery. Caution arises from historical precedents where initially thrilling cases ultimately proved mundane. Science demands not just passion, but rigorous verification and skepticism. The next research directions are clear. We need sustained monitoring of its orbital variations. We require advanced spectral analysis to determine its surface composition. We must listen for any form of radio signal emission. We must also prepare for the highest resolution imaging when it reaches its closest approach to Earth. Every data point could hold the key to unlocking its true nature. 3I Atlas continues its silent voyage along its predetermined path, unresponsive to human attention or conjecture. It exists as an objective entity, moving solely by the laws of physics. Yet this very objectivity poses the deepest questions. What exactly is it? Where did it come from? What secrets lie within its core? These questions fuel humanity's purest spirit of scientific inquiry. In the following chapters, we will delve into the boldest hypothesis proposed to explain these anomalies. That 3I Atlas may not be a natural celestial body, but rather an artificial interstellar probe. As anomalous data from 3I Atlas continues to accumulate, the scientific community must seriously consider non-natural explanations. Professor Avi Loeb of Harvard University's Department of Astronomy pioneered a bold hypothesis. In a peer-reviewed paper submitted to the Astrophysical Journal, he posits that 3I Atlas may not be a rare interstellar comet, but rather an artificial artifact from an extraterrestrial technological civilization. This hypothesis is grounded not in conjecture, but in rigorous scientific analysis. Dr. Loeb's team systematically ruled out multiple natural explanations, ultimately concluding that artificial origin is currently the most compatible possibility with all observational data. The core premise of this hypothesis posits that 3I Atlas is an interstellar mothership, designed to systematically study our solar system, particularly its rocky planets within the habitable zone. As a mothership, it likely carries numerous small reconnaissance probes, ready for deployment at optimal moments to key locations throughout the solar system. This architecture resembles humanity's combination of space stations and rovers, but operates at a scale and technological sophistication far exceeding our current engineering capabilities. The first solid evidence supporting this hypothesis stems from the precision of its trajectory. Natural celestial bodies' orbits are typically heavily influenced by initial conditions and gravitational perturbations, resulting in paths exhibiting randomness and unpredictability. Yet, 3I Atlas's trajectory exhibits remarkable mathematical elegance. It is not simply captured or scattered by the sun's gravity, but traverses interplanetary space along a path calculated for optimal efficiency. This trajectory enables it to visit multiple planets with minimal energy expenditure. Dr. David Jewett's team at UCLA conducted an in-depth analysis, They simulated millions of virtual interstellar objects entering the solar system. They discovered that the statistical probability of an object like 3I Atlas achieving consecutive close flybys of multiple planets is less than 1 in 1,000. While such a low probability event is not impossible, it strongly suggests its trajectory may be subject to some form of intelligent control, or that our understanding of interstellar object dynamics is fundamentally incomplete. The second key piece of evidence lies in its extraordinary rotational stability. Long-term monitoring data from the Hubble Space Telescope reveals that 3I Atlas maintains a constant rotation period, with its rotational axis pointing in a fixed direction in space. Such perfect stability is virtually unheard of among natural celestial bodies. Small celestial bodies typically exhibit complex, chaotic rotation in space due to their irregular shapes and weak gravitational fields. Such extreme stability can be achieved through artificial control. An advanced spacecraft requires maintaining a stable orientation to ensure its solar panels, communication antennas, and scientific instruments point in the correct direction. Internal gyroscopes or reaction wheel systems can actively counteract external torques, thus keeping the spacecraft in optimal alignment throughout its millennia-long journey. The third piece of evidence is the detection of highly reflective metallic patches on its surface. Natural celestial bodies are typically covered by thick layers of weathered material and dust. These substances significantly reduce the surface's albedo. However, localized high reflectivity regions appearing on 3I Atlas's surface exhibit spectral characteristics highly similar to highly polished aluminum or specialized alloys. These areas may function as solar collectors or communication antenna arrays. Mid-infrared observations from the James Webb Space Telescope reveal further details. These highly reflective areas exhibit intricate geometric patterns, including distinct right-angled structures and repeating grid-like configurations. Right angles and regular geometric shapes are exceptionally rare in nature, typically requiring crystal growth or specific geological processes to form. Such large-scale, regular patterns are more likely the product of intelligent design. The fourth piece of evidence comes from the confirmation of an internal heat source. Observations from the Spitzer telescope and subsequent infrared data consistently indicate that the core region of 3I Atlas maintains a temperature higher than its surface equilibrium temperature. This implies the presence of a persistent internal heat-generating mechanism. For natural comets, such an internal heat source could originate from radioactive decay. However, sustaining such prolonged thermal output would require an exceptionally abundant supply of radioactive elements. An alternative explanation suggests this could be waste heat from some form of technological apparatus, such as a nuclear fission or fusion reactor capable of operating for millennia, or an advanced energy system utilizing black hole evaporation principles. These systems could power spacecraft propulsion, navigation, and scientific instruments, or maintain habitable environments for potential biological or artificial intelligence systems. The fifth compelling piece of evidence concerns the peculiar nature of its coma composition. The James Webb Space Telescope detected carbon dioxide concentrations more than 8 times higher than any measured in known comets. This anomalous abundance may indicate that the carbon dioxide does not originate from sublimating ice, but rather as a byproduct of some technological process, such as atmospheric regulation by a life support system, or the exhaust of a propulsion system's working fluid. Even more unusual, spectral analysis reveals specific isotopic ratios within the carbon dioxide. These ratios starkly contrast with known isotopic distributions of carbon dioxide within the solar system. This may point to a source region formed in a different stellar environment, or to artificial isotope separation processes. The latter are commonly employed in various industrial and technological applications within advanced civilizations. The sixth piece of evidence concerns the object's interaction with the solar wind. As 3I Atlas traversed the solar wind, it generated an anomalous plasma wake. The characteristics of this wake indicate the presence of a powerful magnetic field surrounding the object. Both the structure and intensity of this field differ from those produced by natural celestial bodies. It exhibits a high degree of symmetry and stability, as if actively generated by a controlled electromagnetic system. This magnetic field may serve to deflect cosmic rays permeating the Milky Way, protecting the spacecraft's internal precision electronics and potential crew, or function as part of a propulsion mechanism without propellant, generating thrust through interaction with ionized solar wind particles. The seventh piece of evidence supporting artificial origin comes from radio band observations. Although no intentional signals directed toward Earth have been detected, several radio telescope arrays have recorded faint broadband electromagnetic radiation. This radiation exhibits characteristics similar to electromagnetic noise generated by large electronic equipment. Its frequency distribution and intensity variation patterns differ from known natural electromagnetic phenomena. Scientists at the SETI Institute conducted in-depth signal analysis. They discovered faint periodic structures within these emissions. This periodicity may correspond to operational rhythms of internal spacecraft systems, such as computer clock cycles or power distribution system switching frequencies. Although these signals are extremely faint and difficult to decipher, their very existence increases the likelihood of artificial origin. Based on all this evidence, a coherent technological narrative begins to emerge. 3I Atlas may be an autonomous spacecraft from an ancient extraterrestrial civilization, launched into interstellar space millions of years ago. Its mission was to locate and study potentially habitable star systems within the Milky Way. After detecting the habitable characteristics of the solar system, the spacecraft's artificial intelligence system decided to alter its course for a close reconnaissance mission. The spacecraft's hull was deliberately designed to resemble a natural celestial body. This camouflage strategy may represent a protocol to avoid alarming the target civilization, or to reduce the risk of interstellar dust impacts during its long journey. Its teardrop-shaped hull could serve both as camouflage and as a visible effect of some propulsion system. The spacecraft's interior may contain a complete life support system, capable of sustaining potential hibernating life forms or advanced artificial intelligence, or carry genetic or cultural databases, prepared for information exchange with encountered civilizations at an opportune moment. The concept of a mothership also gains theoretical support. It could function as a mobile factory utilizing resources gathered en route to manufacture and launch smaller, specialized probes. These secondary probes may already be deployed throughout the solar system, yet remain undetected due to their diminutive size or highly advanced stealth technology. This hypothesis also explains why 3I Atlas's trajectory is so precise. It must ensure arrival at a strategic location, capable of effectively deploying probes without premature detection. The perihelion behind the Sun represents such an ideal position. Probes launched from there can harness the Sun's gravitational field for acceleration, while Earth-based observers would struggle to detect them due to the Sun's intense glare. Of course, this hypothesis remains widely contested within the scientific community. Many conservative astronomers insist on seeking more conventional explanations. They argue that anomalous data may stem from gaps in our understanding, rather than necessitating appeals to extraterrestrial intelligence. History offers numerous examples of unexplained phenomena, ultimately finding natural explanations. However, Dr. Loeb and colleagues contend that the scientific method should follow the evidence. When natural explanations require stacking increasingly improbable coincidences, considering non-natural possibilities becomes a legitimate scientific inquiry. This is not abandoning scientific principles, but expanding the boundaries of scientific thinking. To test this hypothesis, a global scientific team has devised a detailed observation plan. As 3I Atlas approaches the Sun, We will examine it using every available observational method. Any deployment activity by a probe would constitute definitive evidence of artificial origin. Detailed imaging of surface structures might also reveal traces of construction, even if it ultimately proves to be an exceptionally peculiar natural celestial body. This exploration process has already significantly advanced the field of interstellar astronomy, teaching us how to identify artificial features on celestial bodies, and preparing us scientifically for potential future direct encounters. But if we truly discover evidence of its artificial origin, human civilization will face a historic turning point. We will be compelled to rethink our place in the universe and our relationship with potentially existing extraterrestrial intelligence. This very possibility is the subject we shall explore in depth in the next chapter, namely the profound implications of 3I Atlas as potential extraterrestrial technology. Based on the hypothesis that 3I Atlas may be an alien mothership, astronomers and space agencies worldwide have begun simulating potential reconnaissance missions. These simulations aim to predict the object's possible behavioral patterns and formulate corresponding human observation and response strategies accordingly. Dr. Loeb's team's calculations indicate a critical time window, occurring in late October 2025 when 3I Atlas reaches its orbital perihelion. This position, located on the opposite side of the Sun relative to Earth, creates a natural observational blind spot while simultaneously providing perfect operational cover. Launched from such a concealed location, any small probes deployed from the mothership would gain optimal initial conditions. These potential probes could leverage the Sun's intense gravitational field to achieve the slingshot effect, gaining the extra velocity needed for interplanetary travel, without expending significant amounts of their own propellant. This efficient application of orbital mechanics demonstrates a profound understanding of the solar system's dynamic environment. The precision of their mission planning far exceeds current human space engineering capabilities. Mars will be the first planet to receive this close visit. According to orbital mechanics principles, a probe deployed from behind the Sun could reach Mars with exceptional efficiency. The European Space Agency's Mars orbiter has already adjusted its trajectory to conduct intensive monitoring during its closest approach on October 2, 2025. NASA's Perseverance rover and its aerial assistant, the Ingenuity helicopter, will also gaze skyward from the Martian surface to capture any anomalies. These reconnaissance probes may feature diverse, specialized designs. Some may be dedicated to sampling and analyzing planetary atmospheres. They could delicately penetrate Mars' thin atmosphere to measure its gas composition, dust content, and seasonal variations. Others might be engineered as penetrating probes to drill beneath the Martian surface in search of water ice or even signs of life. Orbiter-type probes may also be deployed. They would quietly enter orbit around Mars to conduct comprehensive mapping of the planet and monitor human activities on its surface. Of greater concern is the deployment of earthbound probes. Probes launched from the Sun's perihelion point toward Earth would possess exceptionally high energy efficiency. They could reach Earth's vicinity in mid to late November 2025. The potential mission objectives for these Earth-directed probes are highly diverse. They might aim to study Earth's biosphere characteristics in detail, including anomalous ratios of oxygen and methane in atmospheric gas compositions, gas combinations often regarded as reliable indicators of life's presence. They may also monitor Earth's radio wave leakage, human communication signals escaping into space since the early 20th century, forming a unique technological civilization fingerprint. The design philosophy of these probes may differ entirely from human spacecraft. They could be extremely small, even reaching nanoscale dimensions, operating in coordinated observation clusters, where the failure of individual units would not compromise the mission's overall objectives. They may employ advanced stealth technologies, such as dynamic camouflage surfaces mimicking the cosmic backdrop or Earth's atmosphere, rendering them nearly invisible to human space surveillance networks. Alternatively, they could disguise themselves as natural space debris, blending among thousands of man-made satellites and rocket remnants. The propulsion systems of these probes represent another critical research area. They may utilize propulsion principles beyond current human understanding, such as propulsion without propellant based on quantum vacuum fluctuation manipulation, or warp drive technology manipulating space-time metrics. These propulsion methods produce no discernible chemical rocket plume, making them difficult to detect with conventional space surveillance sensors. This may explain why we have yet to definitively detect them. Faced with this unprecedented potential contact scenario, global space agencies have initiated a series of emergency response protocols. The United Nations Office for Outer Space Affairs swiftly convened an expert working group, tasked with drafting a protocol framework for humanity's first contact. This framework builds upon decades of theoretical groundwork from the SETI research community, now transitioning from academic hypothesis to practical operational guidelines. The core principles of the protocol are peace, science, and prudence. NASA and the European Space Agency coordinated their deep space networks to broaden the monitoring frequency bands of radio telescopes, not only to search for intentional communication signals, but also to listen for unintentional radiation potentially generated by the internal operations of the probe system. Such unintentional radiation might resemble the electromagnetic noise produced by Earth's electronic devices. Though not designed for communication, it could reveal the presence of technological activity. China's 500-meter aperture spherical radio telescope, FAST, has joined this effort. Its immense collecting area enables detection of extremely faint signals. Simultaneously, Russia's Radio Astronomy Observation Network and India's giant meter-wave radio telescope, GMRT, array, have prioritized observation time for monitoring 3I Atlas. A global space surveillance network has been placed on high alert. Originally used to track satellites and space debris, its sensors are now recalibrated to detect minute anomalous targets. The North American Aerospace Defense Command's NORAD space surveillance system and the European Union's Space Surveillance and Tracking SST network share radar and optical telescope data to identify any emerging unknown objects in near-Earth space. Commercial space companies are also playing a critical role in this global effort. SpaceX has adjusted portions of its Starlink satellite constellation's communication links to allow its ground stations to occasionally passively monitor potential space signals. Other Earth imaging companies like Planet Labs and Maxar Technologies have been instructed to meticulously examine their high-resolution satellite imagery for any aerial phenomena that might not originate from Earth-based technology. The scientific community has developed a detailed, phased response plan. Phase 1 involves confirming the presence of the probe through cross-validation of data from multiple independent observation stations. Phase 2 entails characterization, analyzing its size, shape, movement patterns, and electromagnetic characteristics. Phase 3 focuses on intent assessment, determining whether it is benign, neutral, or threatening through long-term behavioral observation. Crucially, the response plan explicitly excludes any aggressive actions. Even if the presence of an extraterrestrial probe is confirmed, humanity's initial reaction should be observation, not confrontation. This principle is grounded in a rational assessment. A civilization capable of interstellar travel possesses technological capabilities far surpassing our own. Any hostile action could prove futile and dangerous. Simultaneously, an international diplomatic team is being discreetly assembled. Team members include scientists, linguists, and psychologists. Their mission is to prepare for potential communication attempts. Communication content will emphasize humanity's scientific curiosity and peaceful intentions. Communication methods may employ universal languages of mathematics and physics. Examples include prime number sequences, fundamental particle information, or hydrogen atom energy level diagrams. Amateur astronomers worldwide have also received formal requests for assistance. Through a distributed observation network, thousands of backyard telescopes will be directed toward the predicted celestial region. This citizen science initiative not only expands coverage, but also ensures transparency and public engagement in the discovery process. Educational institutions and media outlets are preparing public information materials designed to communicate the situation calmly and scientifically, to prevent societal panic stemming from misunderstanding or misinformation. Psychologists are studying historical patterns of human response to the unknown, to provide expert guidance for a potential collective psychological adjustment period. Religious leaders and philosophers also participated in private briefings. They began contemplating the discovery's implications for their respective belief systems and prepared to assist followers in spiritually processing the event if necessary. Many mainstream religions have stated their doctrines accommodate the existence of extraterrestrial life, with some even viewing it as further evidence of creation's vastness and wonder. In the financial and economic spheres, experts simulated potential market impacts from confirming extraterrestrial technology. Scenarios ranging from short-term panic to long-term technological revolution were considered, ensuring the stability and resilience of the global economic system. The legal community began reviewing existing international space law, particularly the 1967 Outer Space Treaty, assessing whether its provisions adequately govern interactions with extraterrestrial intelligence, and drafting new legal frameworks to address this unprecedented situation. Despite these intensive preparations, a healthy skepticism persists within the scientific community. Many astronomers remain committed to finding natural explanations for 3I Atlas, arguing that maintaining academic rigor is a scientist's primary duty until definitive evidence emerges. Yet all agree on one point. The autumn 2025 observation window is critical. Every astronomical instrument at our disposal, whether ground-based or space-based, will focus on this enigmatic interstellar visitor, attempting to capture any potential deployment activities of its probes. Even if no deployment actions are observed, 3I Atlas's behavior near perihelion holds immense scientific value. Intense solar radiation may trigger new surface activity, providing further insights into its composition and structure. Should probes indeed be deployed and detected, human civilization would face a historic moment. Should we attempt proactive communication or continue observing and listening? This question has been fiercely debated at the highest scientific forums. Some scientists advocate for immediate attempts to establish contact, arguing it represents a crucial step toward humanity's cosmic coming of age. Others urge extreme caution, citing the tragic consequences of civilizational encounters throughout human history as a warning. They advocate for long-term observation to better understand the other's intentions. Regardless of the strategy ultimately adopted, this process must proceed on the basis of international consensus. For contact with extraterrestrial intelligence would represent all of humanity, not any single nation. This realization is fostering unprecedented global cooperation. The potential reconnaissance mission of 3I Atlas is not only an exploration of its own purpose, but also a test of the maturity of human civilization. Whether we can respond to this challenge with unity, reason, and peace may determine our future trajectory in this universe. As the critical time window approaches, humanity awaits answers from the heavens. This very act of waiting has forever altered how we perceive our place in the cosmos. Should the hypothesis of 3I Atlas's artificial origin ultimately be confirmed, human civilization will undergo its most profound paradigm shift in history. This moment will forever divide pre-contact and post-contact eras. Our ancient belief in humanity's unique status in the cosmos will be fundamentally restructured. The question of the universality of life in the cosmos, long pondered by philosophers and scientists, will transform from pure philosophical speculation and statistical conjecture into concrete reality. This implies that intelligent life is not a rare and precious accident in the universe, but may instead be a natural, even universal, outcome of cosmic material evolution. The primary impact of this realization will be philosophical and ontological. We must revisit fundamental questions. What is the meaning of life? What role does consciousness play in the cosmos? Human values and belief systems will face unprecedented challenges. Many geocentric notions will naturally dissolve. We are merely one among many intelligent life forms. This awareness is both humbling and liberating. From a scientific and technological perspective, contact will present immense opportunities for leapfrog development. Simply observing the technological capabilities demonstrated by 3I Atlas points to potential directions for physics and engineering. Its propulsion system, which disregards chemical rocket principles, suggests the possibility of manipulating gravity or space-time itself. This will fundamentally reshape the landscape of human space exploration. Interstellar travel will transform from an unattainable dream into a plannable engineering goal. The communication technologies it may employ, based on quantum entanglement or even more advanced principles, will make our current radio communications seem like Stone Age smoke signals. Information transmission could achieve true instantaneity, breaking the barrier of light speed that limits intergalactic communication. This is not merely a revolution in communication technology. It will profoundly alter our understanding of the very nature of space and time. The marvels it unveils in materials science are equally awe-inspiring. Hull materials capable of withstanding millennia of harsh interstellar travel exceed the strength, toughness, and self-repair capabilities of our most advanced alloys. Once we master the principles behind such materials, they will trigger cascading technological revolutions across architecture, transportation, energy, and beyond. If the 3I Atlas is confirmed as an AI-driven autonomous spacecraft, its significance is equally profound. It would demonstrate that non-biological intelligence can attain, and even surpass, the heights of biological intelligence, while independently executing complex interstellar exploration missions. This offers critical reference points for humanity's own evolutionary choices. We may accelerate our integration with artificial intelligence, or reassess the long-term value of purely biological intelligence in the cosmos. From a socio-political perspective, confirming extraterrestrial intelligence would become an unprecedented unifying force for human civilization. Historical conflicts and divisions among nations, states, and civilizations might drastically diminish in significance when confronted with a shared, external cosmic reference point. Humanity might for the first time genuinely think and act as a unified civilization. This could catalyze new global governance models to coordinate human activities within the solar system and responses to extraterrestrial intelligence. Existing international institutions like the United Nations may need to evolve or be supplemented by entirely new, more representative planetary-level governing bodies. Human legal systems will also require expansion to encompass the ethics and norms of interstellar contact. Economic systems will likewise undergo fundamental transformation. The existence of extraterrestrial technology will open entirely new economic domains and developmental trajectories. Traditional economic models reliant on Earth's scarce resources may gradually become obsolete. They could be replaced by a new economy based on information, knowledge, and cosmic cooperation. Dramatically reduced costs for energy, materials, and transportation will reshape global supply chains. Culture and the arts will witness an explosive wellspring of inspiration. Human mythology, literature, music, and visual arts will be infused with entirely new cosmic themes. We will no longer merely depict Earth's landscapes and human stories, but begin to express the grand narratives of interstellar civilization. Artists from diverse cultural backgrounds will collectively explore how to interpret this new reality. Religion and spirituality will undergo profound self-reflection and adaptation. Doctrines within many religious traditions regarding humanity's unique status will require reinterpretation. This need not lead to the collapse of faith, but may instead open a broader, more inclusive understanding of spirituality, viewing divinity or cosmic consciousness as a universal presence permeating the cosmos. Yet this prospect also carries severe challenges and risks. Insecurities stemming from technological gaps may trigger global anxiety. Compared to an advanced civilization that may have existed for millions of years, the gap between human civilization and such an entity could be as vast as that between ants and humans. This asymmetry of power demands we respond with profound wisdom and humility. Another risk lies in potential new divisions within humanity over how to respond. Should we engage proactively and enthusiastically, or retreat cautiously into concealment? Different response strategies could create fractures between nations and cultural groups. Avoiding new conflicts on Earth driven by fear or misunderstanding will be crucial. The peaceful, scientifically observational approach demonstrated by 3I Atlas itself signals profound hope. It exhibits no aggression or territorial claims, behaving more like a dedicated scientist than a conqueror. This suggests a highly advanced technological civilization may inherently lean toward peace and exploration, rather than destruction and domination. This partially alleviates the long-standing fears instilled by science fiction narratives, even if 3I Atlas ultimately proves to be a peculiar natural phenomenon. The global scientific exploration itself has already yielded invaluable legacies. It demonstrates humanity's capacity for unprecedented cooperation when confronting profound unknowns. It advances our observational technologies, data analysis capabilities, and theoretical models. It prepares us for potential future encounters with extraterrestrial life. More significantly, this process reignited public interest in fundamental science. It reminded us that the universe remains filled with unsolved mysteries, awaiting exploration by curious and courageous minds. It demonstrated to the next generation that science is not merely formulas in laboratories, but a grand adventure brimming with wonder and discovery. From cosmology's grand perspective, the emergence of intelligence may be the universe's way of knowing itself. We humans, and any other extraterrestrial civilizations that may exist, are vessels through which the universe manifests its reflective consciousness. Through our eyes, the universe observes its own grandeur. Through our science, the universe comprehends its own laws. Through our art, the universe appreciates its own beauty. The arrival of 3I Atlas, whatever its nature, invites us to participate in this grand process of cosmic self-awareness. It urges us to transcend personal anxieties and regional conflicts, to turn our gaze toward a shared future among the stars. In this future, humanity may no longer be a solitary species, but a new, fledgling yet promising member of the galactic community. Ultimately, the most precious revelation this event leaves us may not lie in the specifics of extraterrestrial technology, but in our own humanity. It tests our courage, wisdom, and unity in the face of the unknown. It measures whether our young civilization is ready to assume the role of a conscious, responsible agent in the vast cosmos. While awaiting the final answers to unfold, the best preparation we can make is to continue nurturing the spirit of scientific exploration, to foster global cooperation and understanding, and to safeguard the peace of our fragile planet upon which we depend. For whatever secrets the stars may hold, a united, curious, and hopeful human civilization will always remain the most solid foundation for embracing any future. As observational data continues to accumulate, we stand at the threshold of a new era, an age potentially filled with wonders and challenges beyond our current imagination. Yet as long as we uphold the spirit of peaceful exploration and the pursuit of knowledge, the future of human civilization will be as vast and luminous as the cosmos itself. The critical observation window has finally arrived. Observatories worldwide have trained their lenses on the predicted perihelion location of 3I Atlas. This moment crystallizes months of collective scientific effort and anticipation. From Chile's giant mirrors to the orbiting Hubble and Webb telescopes, all operate at unprecedented intensity. Data surges like a torrent from observatories to processing centers. Scientists analyze every byte with bated breath, scrutinizing subtle shifts that might reveal its essence. Under the intense sunlight at perihelion, surface activity on 3I Atlas indeed reached its peak. Its teardrop-shaped coma grew brighter and more complex. Spectral analysis indicated increased release of volatile substances. Yet no clear evidence emerged of a large subprobe separating. Its overall structure maintained surprising integrity. This outcome left scientists supporting the artificial origin hypothesis somewhat disappointed, while researchers advocating natural explanations breathed a sigh of relief. But the story is far from over. Detailed analysis reveals a more intricate picture. High-resolution images show anomalous temperatures in metallic patch regions on its surface. These areas did not heat up as rapidly as surrounding regions under intense sunlight. Instead, they maintained a relatively stable temperature range. This strongly suggests the potential existence of an active thermal control system beneath these regions. Perhaps a cooling mechanism protecting precision instruments is operational. Simultaneously, radio astronomers detected a series of extremely brief, narrowband pulses. These pulses lasted less than a millisecond and did not repeat. They were difficult to discern, hidden within the background noise of solar radio bursts. Only after complex signal processing did they become visible. Though these pulses carried no decodable information, their artificial construction was highly evident. They likely represent electromagnetic leakage from some internal system under specific conditions. As 3I Atlas journeys further from the Sun, embarking on its departure from the solar system, human observation conditions will gradually become challenging. Its brightness is rapidly diminishing, and it will eventually fade back into the stellar background. But this time, we are no longer unprepared observers. We have gathered an unprecedented wealth of data, enough for scientists worldwide to analyze for years to come. Regardless of the final conclusions, 3I Atlas's visit has forever changed us. It revealed cosmic phenomena far beyond our imagination. It taught us to approach the unknown with greater openness. It demonstrated the power of global scientific collaboration in tackling monumental challenges. This silent interstellar traveler left us not merely orbital data and spectral charts, but a precious gift of curiosity and the spirit of exploration. The essence of science lies not in obtaining all answers immediately, but in ceaselessly posing better questions. 3I Atlas has brought us countless new questions. What is the true diversity of interstellar celestial bodies? How do exoplanetary systems fundamentally differ from our solar system? Does the distribution of matter and energy in the universe contain forms unknown to us? These questions will drive the direction of astronomical research for decades to come. Even if 3I Atlas is ultimately confirmed as a natural phenomenon, it remains undoubtedly the most extraordinary natural phenomenon discovered to date. Its peculiar properties will compel us to rethink theories of planetary system formation. Perhaps within the vast void between stars lie celestial formation mechanisms beyond our imagination. Mechanisms that could produce natural objects bearing partial artificial characteristics. And if future analysis ultimately leans toward the hypothesis of artificial origin, Human civilization must begin earnest preparations for the next phase. We may need to establish permanent interstellar object monitoring networks, develop more sensitive detectors, and more powerful data analysis tools to be fully prepared for the next interstellar visitor, while continuously monitoring any signals from the direction of 3I Atlas. Perhaps it is merely silently recording and transmitting, awaiting the moment when we evolve sufficiently to comprehend its message. From a broader cosmic perspective, the emergence of 3I Atlas is merely the beginning. It marks humanity's formal entry into the era of interstellar archaeology. We now view the solar system as a space potentially visited by others, a realm possibly strewn with traces of extraterrestrial technology. Future space missions may include objectives to seek such traces, whether on the lunar surface, Martian deserts, or within the asteroid belt. This exploration also underscores the irreplaceable value of fundamental science. The telescope that first discovered the 3I Atlas was not built for searching for extraterrestrial civilizations. It was merely performing its routine sky survey duties. It is precisely this pursuit of foundational knowledge that has yielded unexpected breakthrough discoveries. This reminds us of the importance of supporting pure scientific research, for the next game-changing discovery may be hidden within a research field we currently deem impractical. For the public, the story of 3I Atlas holds profound educational significance. It reveals the true nature of the scientific process to the world, not instant answers, but continuous questioning, verification, and revision. It shows how scientists maintain caution when evidence is scarce, and rigorously weigh multiple possibilities. This scientific mindset is humanity's most precious intellectual asset. For each of us personally, this story invites us to gaze once more at the night sky, with childlike wonder and a thirst for knowledge, to ponder those eternal questions. Are we alone in the cosmos? Does other forms of consciousness and intelligence exist in the universe? The significance of these questions lies not in immediate answers, but in how they inspire us to continually transcend our own limitations. The journey of the 3I Atlas will eventually conclude, but humanity's quest for exploration is endless. Next-generation space telescopes are already in the planning stages. They will possess greater capabilities to observe fainter interstellar visitors. Future space probes may carry specialized instruments to search for similar objects in the Kuiper Belt or even the Oort cloud. Our understanding of the universe deepens through such cycles. In the not-too-distant future, humanity may launch our own interstellar probes, heading toward the direction from which 3I Atlas came, carrying the flame of curiosity and exploration back to its source. At that time, all our efforts and waiting today will become a memorable starting point in humanity's grand narrative of reaching for the stars and the vast seas. The mysteries of the universe are not exhausted by a single discovery, just as the ocean does not dry up when a river flows into it. Behind every answer lie more questions. The end of one exploration heralds the beginning of a new journey. This infinite openness is precisely the deepest allure of the cosmos. Thank you for accompanying us on this extraordinary journey of scientific inquiry. With such a calm and focused mindset, whether you are a professional researcher or a curious observer, you are an indispensable part of this story of exploration. For science ultimately belongs to all of humanity. If you wish to continue this journey of cosmic discovery, please subscribe to our channel and turn on notifications. We will continue tracking the latest research developments from 3I Atlas and explore more cutting-edge discoveries in astronomy with you. From analyzing exoplanet atmospheres to black hole event horizons, from mapping dark matter distributions to precise measurements of cosmic expansion, the frontiers of science are boundless, and our exploration will never cease. Share your thoughts on the ultimate nature of 3I Atlas in the comments section. Do you see it as an unprecedented natural wonder, or humanity's first encounter with extraterrestrial technology? Should we actively attempt communication with such visitors? What do you most hope to learn from this discovery? Every thought you share becomes part of this great dialogue. Look up at the stars. Carrying the insight's 3-eye atlas has left us. In this boundless universe, stay curious, stay in awe. But most importantly, keep the courage to explore. For the greatest discoveries always await the next generation of explorers. And you are those future discoverers. Farewell, 3-eye atlas. Whatever you are, wherever you come from. Thank you for opening this window to new cosmic horizons. May your journey continue through endless stars. As an eternal symbol of humanity's spirit of exploration. In the vast cosmos, we shall meet again.